Okay, something really big has been brewing over at Google. In just the span of a few days, they've quietly unveiled 3 major AI innovations. And what's so interesting is that they're in completely different fields, but they all share this incredibly ambitious goal.
And that goal really gets to the core of what we're talking about today. It's this question: can AI genuinely replicate the complex, messy, and frankly human processes of an expert? We're way past simple automation here. We're asking if AI can handle those high-level, multi-step jobs that have always been done by specialists.
Well, it turns out Google is trying to do exactly that. They've just launched 3 brand new AI agents designed to tackle that very problem. So, let's break down how they work, what really makes them different, and why this might be a pretty significant shift in what AI can do. All right, let's get into it.
First up, we've got an agent that's designed to take on the creative, often chaotic process of academic research. It's called Test Time Diffusion Deep Researcher, which is a mouthful, so we'll just call it TTDDR. And it's built to get into the weeds, to mimic how a human researcher actually thinks and writes.
The core idea here is, honestly, brilliant. TTDR treats the whole research process like cleaning up a blurry image. You start with something kind of noisy and undefined, and then, step by step, you refine it, sharpen it, until suddenly you have a crystal clear picture. TTDR does that with words, starting with a messy first draft and just constantly iterating until it becomes a polished final report.
And this is where you see the huge difference in its approach. Older AI agents were kind of like a bunch of separate tools just duct taped together. You had a planner over here, a search tool over there, and a writer somewhere else. TTDR is totally different. It's one single integrated process. And crucially, it doesn't just rely on its old training data. It's constantly pulling in fresh information from the outside world at every single step.
And here's what that journey actually looks like in practice. It plans its attack, it searches for info, it refines the draft, writes a new version, and then, this is key, it rewrites it again based on its own self-critique. See, it's not a straight line from A to B. It's a loop. It's iterative, just like how a real person works, constantly finding new puzzle pieces and reshaping the whole picture.
And the results? Well, they're pretty striking. When they put it head-to-head against a similar system from OpenAI on really complex research questions, human judges preferred TTDR's long-form reports almost 75% of the time. I mean, that's a huge win rate. We're talking 3 out of 4 times, which shows just how good it is at staying focused and coherent on big tasks.
All right, so from messy research papers to coding. Let's see how this same philosophy works in a completely different world. Our next agent is called MLE Star. And listen, we're not just talking about spitting out a few lines of code. This thing is designed to autonomously build an entire competitive machine learning pipeline from scratch.
One of the coolest things about it is that it doesn't have like a fixed playbook from 2 years ago. If you give it an image classification job, it won't just default to an old standby like a residual network. Nope. It actively goes out and looks for what's state-of-the-art right now, and it'll pick something newer and better like a vision transformer. It adapts to the problem.
Okay, but let's be real. Anyone who's tried to use AI to generate code knows the #1 problem, right? It just breaks. It hallucinates functions that don't exist, or it makes these tiny little errors that bring the whole thing crashing down. So how does MLE Star get around that?
It has these 3 awesome safety nets built right in. First, a debugging agent that automatically catches and tries to fix errors as they happen. Second, a data leakage checker that scans for huge security no-nos, like accidentally training the model on the test answers. And third, a data usage checker, which just makes sure the agent didn't forget to use a piece of data you gave it, which happens more than you'd think.
And the proof is in the performance. They tested it on a bunch of Kaggle competitions, and MLE Star won medals in almost 2/3 of them. And get this, in over 1/3 of those competitions, it took home a gold medal. That's not just an improvement, that's playing in a whole different league compared to what came before.
All right, so we've covered research, we've covered expert-level coding. So where do we go from here? How about the entire planet? Our third agent is from Google's DeepMind. It's called Alpha Earth Foundations, or AEF, and its job is to understand our whole world.
The absolute best way to wrap your head around AIF is to think of it as a virtual satellite. It's an AI model that thinks decades of data, from satellites, drones, climate models, you name it, and blends it all together into one unified picture of the Earth. It's like having a satellite that can be anywhere at any time instantly.
And the level of detail we're talking about here is just mind-boggling. AFE creates these data maps at a 10 by 10 meter resolution for the entire planet. Every single one of those little squares contains this rich, dense information about everything from the climate and terrain to plants and buildings.
But here's the kicker, and this part is just wild. AEF manages to pack all of that rich data into a format that is 16 times smaller than even the most compact traditional models. And it does it with zero drop in performance. It's unbelievably powerful, but also incredibly efficient.
But maybe its most game-changing feature is this: creating maps on demand. You need to see what a particular forest looked like back in 2017? Done. Need a map of some region that was totally covered by clouds on the last satellite pass? AEF just fills in the gaps. No more waiting, no more manual data stitching, no more clouds. You get a clean, analysis-ready map right now.
So, we've got a researcher, a coder, and a planet mapper. They seem totally different, right? Doing completely separate jobs. But are they? What's the common thread that actually ties all of these powerful new AI agents together?
Well, when you step back and look at all three, a really clear pattern emerges. There are a few core ideas that connect them all. First, self-evolution. They all learn from their mistakes and actually reconfigure themselves to get better. Second, real-world integration. They are not stuck in the past. They actively go out and pull in current, external info. And third, expert-level autonomy. They're all designed to handle a complex task from beginning to end, the way a human would.
So you see, this isn't just about writing a better research paper or some cleaner code. This is about a fundamental shift toward building autonomous agents that can learn, adapt, and operate in the real world on a massive scale. And when you realize that, it kind of leaves you with one final, pretty provocative question to chew on. What is the most dangerous potential use of this technology?